Dependency injection, often abbreviated as simply DI, is a design pattern that supports the development of loosely coupled code. The use of dependency injection supports implementation of two related concepts: inversion of control and the dependency inversion principle. Dependency injection is a foundational concept in ASP.NET Core, upon which the rest of the framework relies heavily. It is strongly encouraged that developers take advantage of dependency injection when building ASP.NET Core applications. In fact, you must work quite hard against the framework to avoid using it. We'll begin by identifying some architectural problems inside the tennis booking application. This page is the homepage for the fictional tennis club. At the top of the homepage, the owners have a requirement to display the current weather conditions near the club. Since I'm based in the UK, perhaps I could have just hard-coded this as a rainy forecast. Here is the ASP.NET Core Razor page model, which handles requests for the homepage. It has an onGet method, which populates the model used to build and return the homepage content. This method currently uses a class called Random Weather Forecaster to get the current weather conditions. To produce the page model, the onGet method calls a method on this class. This is known as a dependency because the onGet method and the index model class is now dependent on the Random Weather Forecaster to complete its job. Currently, the index method is responsible for the creation of the Random Weather Forecaster instance on which it depends. It does this using the new keyword. Whilst everything works as expected, there are a few problems with this current approach. Because it's responsible for creating an instance of the Random Weather Forecaster, the onGet method is now tightly coupled to the current Random Weather Forecaster implementation. Tight coupling is considered an anti-pattern in software development because it makes it harder to maintain code. Well-factored code will include dependencies between classes, but we want to avoid directly coupling those classes together. To illustrate why this current design can be problematic, imagine a requirement to add an improved weather forecasting implementation to the application. We can expand the tennisbookings.shared class library project and right-click to add a new class. Let's call it Amazing Weather Forecaster. We'll include a getCurrentWeatherAsync method on this class, which accepts a city and returns a weather result. For reasons that will become apparent later, I'm making this method asynchronous, which means the result is wrapped in a task. We'll have this implementation always return a fixed result, where it's sunny every day. That would be pretty amazing. If we want the onGet method to use this implementation, then we must update its code to create an instance of the Amazing Weather Forecaster instead of the original Random Weather Forecaster. Now, this makes the application harder to maintain because changes downstream can ripple through layers in the codebase. A second problem arises when we want to unit test the onGet method. The onGet method has logic for adding a weather description to the view model for the page, and this is based on the weather result from the weather forecaster. Now, it would be reasonable that we want to test that the expected weather description is set on the model for each of the possible weather results. Inside the test project, there are two unit tests that begin to cover this scenario. I'll right-click inside the class and choose Run Tests from the menu. Oh no, one unit test has failed. The test expects to cover the case where the rain condition is returned. Because the onGet method is responsible for creating the weather forecaster dependency directly, when under test we can't control the implementation that's used, nor the result that the getCurrentWeatherAsync method returns. The Amazing Weather Forecaster implementation returns a sunny weather condition every time it's invoked. So at this point, reliably testing the logic of our index model is pretty tricky. We'll resolve this later in the module once we've refactored the application. Before we continue, let's switch the onGet method back over to using the Random Weather Forecaster for the time being.